Well, when we did our unit circle, remember our hypotenuse was always 1. That's how we came up with the fact that if I was looking for the sine of theta, which was opposite of our hypotenuse, we just said, well, that's y over 1. In other words, it was just our y value. Which is really helpful because once we have the unit circle, we can get those values of those given angles. We did the same thing with cosine, except cosine is adjacent over hypotenuse, which gave us x. All right, let's talk about cosecant and secant first. Those are the ones on the right. Cosecant is just the reciprocal of sine. In other words, it's just 1 over whatever sine is. So it's 1 over sine. So that means if sine was 1/2, it would just be 1 over 1/2, which would give us 2. So the shortcut to cosecant is once you know that y value on the unit circle, you're just going to go 1 over whatever that y value is. All right, so up till now, if I said give me the sine of, say, let's just do pi over 4, you'd say it's square root of 2 over 2. If I wanted the cosecant of that same angle, you would just take the reciprocal of it, which would be 2 over square root of 2. We had to get rid of the radical, but we'll see that in a second, but that's all you need to do. Same thing for cosine and secant. Secant is just the reciprocal of cosine, so this is just going to be 1 over whatever our x value is. So not only do we know the values, we also know if they're positive or negative. Because they're going to be positive and negative in the same place where sine is positive and negative, and secant's going to be the same positive and negative wherever cosine is positive or negative. All right, tangent. Well, tangent can be broken down into just sine over cosine. But with the unit circle, we know that sine equals y and cosine equals x, so we can replicate that as just finding our y and x values and putting y over x. Cotangent is just the reciprocal of tangent, so we're just going to flip it, and so it's going to be x over y. We already know how to find x, we already know how to find y because we memorized the whole unit circle. We memorized where those were going to be at any given point. So in fact, we know all of these values. We just have to plug in our x and y values in the right place. So let's get our positive and negative down first, and then we'll just see how this looks. All right, all students take calculus. First quadrant is all. That means all are going to be positive. Quadrant 2 is students. We said that's where sine is positive. But if sine is positive there, so is cosecant, because they're just reciprocals of each other. So that means cosecant is also positive. All students take. Tangent is going to be positive in my next quadrant, which means cotangent is going to be positive. And finally, calculus is cosine is going to be positive, and so is secant. Secant will also be positive. So that means if I ask for a value of any given angle, so let's say it's 7 pi over 6, you would just have to know that 7 pi over 6 is in our third quadrant. You would know that because the numerator is 1 bigger than the denominator. That's always going to be our third quadrant. If I said 5 pi over 6, that would be in quadrant 2, because it's 1 less. Yeah? Oh, what did I mess up? Oh, yeah.
Cot? Is that supposed to be cot? Or is it supposed to be...
I'm confused. It's cotangent.
Oh, cotangent.
Oh, okay.
It's cotangent's positive. Sorry, it looks like 2 t's, doesn't it?
Yeah.
Maybe I should have circled that or something. Nick, did you have a question too?
What is CSC?
Cosecant. So this is a rehash of geometry. Secant, cosecant, cotangent. All right. So since we already know how to find our x values, we know how to find our y values because we memorize those around the circle. We can find all the other ones to our special angles. They're just the ones that come out to nice numbers. So I'm just going to go around the unit circle. So sine of pi over 6, that's the first tick mark. Sine is always 1/2. At pi over 4, sine is square root of 2 over 2. And at pi over 3, that's our third tick mark, right? 1, 2, 3. That is where it's going to be square root of 3 over 2. Once I know the sine value, you should know the cosine value right off the bat. Because if sine is 1/2, that must mean that cosine is square root of 3 over 2. If sine is square root of 2 over 2, that must mean that cosine is square root of 2 over 2 as well. And finally, cosine of pi over 3 is going to be 1/2. And all of these should be positive because all these are in the first quadrant. All right, we're in the first quadrant, so that means sine, cosine, tangent, cotangent, cosecant, and secant will all be positive. So we don't have to worry about negatives or positives. All right, our tangent value. Our tangent value is always going to be whatever our sine is over whatever my cosine turned out to be. Well, my sine is 1/2. So the tangent of pi over 6 is going to be 1/2 over square root of 3 over 2. Now if we do keep, change, flip, I'd keep the 1/2 and I'd multiply it by 2 over square root of 3, which is going to result in 1 over square root of 3. But we can't have a square root in the denominator, so I'm going to multiply that by square root of 3 times square root of 3. And we're going to end up with square root of 3 over 3. Cotangent is just the reciprocal. Yes?
How did you get...
Did I mess up somewhere? No. No, that's right.
How did you get 1/2 over squares of 3 over 2 in the first place?
What's the sine value at pi over 6? What's the cosine? So we said earlier that tangent equals whatever my sine value is over whatever my cosine value is at that angle. So I just took my sine value of 1/2 and threw it on top of my cosine value, which is square root of 3 over 2. And then I simplified. Yeah.
So for like a tangent, they're all over 2, and we just use like the first value, like
The top value and that value? Yes, absolutely. Yep. I don't feel like shortcutting it. I mean, it works every single time, but that's a whole new rule we got to bring in, and I'm just going to leave keep, change, flip, unless you know. Yes. But that's true. David brought up the fact that if they have the same denominator, we're just going to keep the numerator of the top one and the bottom one. It's always going to work that way if they both have the same denominator. So if this is 1 over 3, square root of 3 over 3, it would still just be the two tops. All right, cotangent, that's a reciprocal. Most of the time you're going to see tangent at pi over 6 is just square root of 3 over 3. You could think that the reciprocal of that is going to be square root of 3, and that's what it's going to turn out to. But I'm just going to take the reciprocal of this one. All right, I'm going to take the reciprocal of the one that we see more often. So if I'm looking for cotangent of pi over 6, I would say, well, tangent of pi over 6 is square root of 3 over 3. So that means the cotangent is the reciprocal, which is 3 over square root of 3. Multiply the top and bottom by square root of 3 to get rid of that darn radical, which would be 3 square root of 3 over 3, which is going to result in square root of 3. That's also a nice trick with radicals. If you ever have a number over a radical and it happens to be the same number, so I have 3 over square root of 3, the simplified form is always going to be square root of 3. If this was 2 over square root of 2, it would be square root of 2. If this was 100 over the square root of 100, it would be the square root of 100, which would be 10. But that was a bad example, but it works nonetheless. All right, secant. Secant is the reciprocal of cosine. So you just have to know your cosine value at pi over 6. Our cosine value of pi over 6 is square root of 3 over 2. So secant is going to be 2 over the square root of 3. Multiply the top and bottom by square root of 3. And we're just going to get 2 square root of 3 over 3. And I can't simplify that any further. So that's the secant of pi over 3. Finally, cosecant. Cosecant deals with my sine. So I just have to know my sine value at pi over 6. Hey, I know it's 1 over 2. So my secant is going to be 2 over 1, which just equals the big deuce. All right, now we're just going to do the exact same thing for the next two columns. Follow the same pattern. All right, so I already know my sine and cosine. So my tangent is sine over cosine. So that's square root of 2 over 2 over square root of 2 over 2. I know it's a fraction on top of a fraction, but I don't need to do is keep, change, flip, because it's the same thing over the same thing. So it's just going to equal 1. Cotangent is the reciprocal of 1. So instead of 1 over 1, it's going to be 1 over 1, but the different ones on top, but it's still just going to be 1. The reciprocal of 1 is still 1. Secant. Secant deals with my cosine. My cosine is square root of 2 over 2, so my secant is going to be 2 over square root of 2. Like I said, if you ever have a number on top of a square root, but they're the exact same number, your answer is just going to be square root of 2. If you don't remember that, just multiply the bottom and top by your radical, and you would see that it actually equals square root of 2. Because it'd be 2 square root of 2 over 2, which is square root of 2. Cosecant is the reciprocal of sine, so it's going to be 2 over square root of 2 as well. But we know that equals square root of 2 because we just did that math. Nick, are you better at where we're getting these tangent values and stuff?
Yeah.
Okay, kind of? Okay. Okay. All right, tangent of pi over 3. Nick, what goes on the top of this fraction if I'm doing the tangent of pi over 3?
Square root of 3 over 2.
There you go. And the bottom is going to be 1/2. We could use David's rule here. We'll call it David's rule from now on. If I have two fractions on top of each other and they have the same denominator, we're just going to end up with the two numerators. In other words, square root of 3 over 1, which is just going to be square root of 3. If you don't remember that, you can always do your keep, change, flip, which would be square root of 3 over 2 times 2 over 1. So that's just going to equal square root of 3. Cotangents are reciprocal. The reciprocal of a number, right? Because square root of 2 is really square root of 2 over 1. So the reciprocal is going to be 1 over square root of 3. I don't like radicals in the denominator, so we multiply by square root of 3, multiply by square root of 3, and then we get square root of 3 over 3. Secant, we look at our cosine value. Cosine was 1 over 2, so this is 2 over 1, so it just equals 2. The other one is 2 over square root of 3, because that's our sine. Multiply top and bottom by square root of 3, and we're going to come out to 2 square root of 3 over 3. Once more, I'm going to ask myself, do I have my positive and negatives correct? We are in the first quadrant, so they should all be positive. I shouldn't have to worry about anything like that. All right, any questions on any of those values? Does anyone need me to hold this up just for a little bit longer so they can make sure they got it right? Okay. Next section, I'm going to leave this mostly up to you. What would probably be a good idea on this one is, let's look at sine of 4 pi over 3. So we'll look at that second column. How What's the trick to know that's in the third quadrant? I don't even have to picture where it is, Jeff.
This is one after the numerator is one after the numerator.
Yep. No, I got you, yeah. 4 is 1 bigger than the numerator, so it's automatically third quadrant. If this would have been 2 pi over 3, it would be the second quadrant. If it's something other, kind of like the 7 pi over 4, then it's going to be in your fourth quadrant. So you should be able to just look at it, not even have to think about all the numbers. You should just be able to quickly go second, third, fourth quadrant. Because if I know this is in the third quadrant, all students take calculus. That means tangent and cotangent are positive. So if I was on a test, I would just go, okay, that's positive. Tangent is positive. I zoomed way too far in. Tangent would be positive. So the rest of them need to be negative. So if I was taking a test, I might just do that right off the bat. Just so when I have my answers, I make sure I either write it correct, or the person that's grading it realizes that even if I drop this negative sign, I knew it was there. I just was going a little faster. I just completely forgot. But at least you knew it was supposed to be negative.
Would you give them credit if you forgot if we had it?
Probably. Sometimes when that happens, I put a little note on it that says don't forget to, and I won't put my correct sign on it, but I won't take any points off. So it's kind of like, it's not correct, but I didn't take any points off for it. Don't do it again. Because I like when you do extra work. I like when you show extra work. I give you as many points as I can if you show extra stuff. It's people that do everything in their head that lose the most points on wrong stuff. All right, you're going to be in charge of filling out this entire table. Remember, I'm looking for exact values. We're not using our calculator. And I say that because I'm going to skip, before you get started on this, I'm going to skip to these 3 problems here. I'm going to talk for a little bit, and then I'm going to release you to do the top, finish this, and then you can work on your homework. All right, this is, we're going to approximate values rounded to 4 decimal places. So the first thing I have is secant of pi over 12. So let's go ahead and take out our calculators. And I just want you to locate your secant button, and then just do secant of pi over 12. So all you need to do is locate your secant button. You just have to locate your secant button. If you found a secant button, either you have a magical calculator or you found the wrong button. There is no secant button on Texas Instruments or Casio graphing calculators. It is not that sign with the negative above it, because that's inverse. There is no dedicated button. But what we can think is, hey, I'm smarter than a calculator.
Oh, something over something.
Oh, secant is just the reciprocal of cosine 1 over cosine of pi over 12. That is something I could definitely plug in my calculator because I have a dedicated cosine button. So do not use that inverse button. Do not use that inverse button. That's completely different. We have a completely different lesson on inverses. What should I be careful about before I just plug this in? Because you might get the wrong answer. Yeah.
Make sure it's set to radians.
Make sure your calculator's set to radians. So as a quick review of how to do that, your mode button is right next to your second button. So you'd hit mode. You would hit mode, I said. I said that you'd hit mode. Oh, mine's not even on. There we go. Mode. I would scroll down. Mine's in radians, so I don't have to do anything. I'm going to go ahead and hit clear, or you can hit second quit to get out of there. Clear works in this menu. And then we're just going to do 1 divided by cosine of your pi is right above your caret button. So you have to hit second pi divided by 12. And so I think it says round to 4 decimal places, maybe? So it'd be 1.0353 would be your answer. 1.053. 035. Did I just...
Yep.
I phased out for 1 second? It happens. It happens. 1.035 trace. All right, then you're going to be responsible for the next two. I want to talk about that unit circle that's right below. It would be very handy, and I do expect you to know all of your tangent values. And it'd be handy to have them memorized, because it's just 3's and 1. All right, it's just square root of 3 over 3, 1, or square root of 3. I say that because I'll give you lots of tangent values. All right, I'll give you cotangent value. I'll ask for cotangent values. You want to have tangent memorized because it's going to be a lot quicker. Yes, you can calculate it, but you should have these memorized. Like if I gave you a quiz on the unit circle again and made you put the tangent values on, you probably don't want to have to calculate all the tangent values. You probably want to have them memorized. All right, don't worry about secant, cosecant, cotangent. Those are easy to figure out once you know them. But tangent you should have memorized. Now you'll notice I only have half of it done. So we're just going to fill in the rest. Well, if we know anything about cosine and sine, we know that the numbers repeat themselves. So if this is square root of 3 over 3, 1 square root of 3, I'm going to skip that undefined for 1 second. We're going to get to square root of 3 on this side. And then it's going to go 1. Well, that's nice. 1 is always right in the middle dot. And then it's going to be square root of 3 over 3.
Wait, didn't you just say 2 square root of 3 on the top?
No.
You did say that, but you meant to say
Oh, I said it out loud?
Yeah.
On which one? On this one?
the radical
Just the
theory.
rest.
Oh, I said 2 radical 3?
Yeah.
Oh, okay. Yeah, I just meant just... Oh, maybe I meant another radical... Anyway, it's square root of 3.
Are they all supposed to be negative?
They're all supposed to be negative because it's all students. And let's see if that makes sense. So tangent is sine divided by cosine. Well, sine is positive, but cosine's negative, so that's a positive divided by a negative, which would result in a negative number. All students take, well, let's carry this really quick. Well, sine is 0. 0 divided by negative 1 is going to be 0. Then we're going to repeat the square root of 3 over 3. 1 square root of 3, well, that's not hard to remember. Should these be positive or negative? Quadrant 3. Positive. And it makes sense because it's a negative divided by a negative number, which makes it positive. Can someone tell me why I have 2 undefines for my tangent values? Jeff?
Because they're 1 over 0 and negative 1 over 0.
Yep. We got a 0 as the denominator, so it's going to be undefined there. Bless you. Real quick, I want to talk about something. Cotangent. If tangent's undefined, does that automatically mean that cotangent is undefined there? Because they're reciprocals.
No, it wouldn't.
And before you give me an answer, think about it this way. Tangent is 1 over 0, so it's undefined. If I take the reciprocal of 1 over 0, what would that be if I just flip them? 0 over 1, is that undefined?
Yeah.
No, it's not. You can do 0 over 1, it equals 0. So once again, if tangent's undefined, does that automatically mean that cotangent's undefined there as well? Who thinks it is? So tangent's undefined, who thinks tangent is undefined as well? Cotangent is undefined as well. Who thinks it is not undefined, that in fact equals 0? It's a 50-50 shot. How come there's only... Let's try it again. All right, tangent is undefined. Does that automatically mean cotangent is undefined? Who thinks it's undefined? Cotangent's undefined there. Who thinks it equals 0? What was that?
Is this a trick question?
No,
Yeah.
it isn't. Let's wait till everyone at least takes a guess. All right, who thinks it is undefined? Cotangent is undefined. Who thinks it is not undefined?
Nick, you raise your hands.
Yeah, I wasn't.
You raised it twice.
Okay. It is 0. Yes, cotangent would be 0 there. But cotangent would be undefined here, because here, even though tangent would be 0 over 1, cotangent would be 1 over 0. It is key to know where cotangent and tangent are undefined. Okay? All right. Then your job right now is A, for homework, make sure you have this memorized with tangent. It really doesn't add much. It's square root of 3 over 3. I don't know. It's fair game, but I guarantee there will be one at some point. Well, I'm 90% sure they will have one. I don't know if it's tomorrow or not. I try to pick a short lesson to do it in. Okay, so your job is to finish these. I will put the solutions up to these in a second. And finish the calculator one, and then use that time to start the homework. If you are working very efficiently, you should be able to get most of your homework done, if not all. But before you leave, make sure you have this filled out, at least this section filled out.